Hi, in this video we're going to be trying to fix up this Shark brand air purifier. I saw this on eBay for spares or repair and I paid £31.88 for it. I'll just bring the listing up so you can have a look. And in the listing it says the power light doesn't show and the unit usually switches itself off shortly after being turned on. And the seller said he believes there's a fault with the power supply and he's been searching for parts for it for about 2 years. Right, so what I'll do then, I'll connect it up to the mains and we'll see exactly what it's doing. Right, I've got it plugged into the mains and there should be a power light up on the front here, which is also the touch button. But because we can't see where the button is because there's no light on it, we don't know how to switch it on. But he did send the remote, so we'll try the remote. It looks like it's sprung into life there. Now there is a button there that's lit up but not very bright. But there's also an auto button which should be about here, which isn't lit up. I think yeah, that's where the power button is, about there, but you can't see it. So I will leave it for a while, we'll see what happens and we'll see if it switches itself off or not. I did have a look at the reviews on the Shark site and there's a few people have said that they've got the same problem with the unit where it just randomly switches off and then if you unplug it, plug it back in, it works sometimes for a few seconds and then it just goes straight off again. So let's just leave it a little bit longer. There we go, it's just switched off there now when I hit the auto button. So that's it off now and it won't switch back on. So it's a bit big to fit on the blue mat. So what I'm going to do, I'm going to take it over the other workshop where I've got a bigger workbench where I normally work on mechanical stuff to take it apart. Then we'll bring the stuff back over to the blue mat and we'll see if we can repair it. Right, got it over the workshop. I've put some bubble wrap on the bench there just to protect it. I've just been upgrading the bench in here. I've just been putting some nice ducats on the backboard that I fitted there. And tool rack there. I've put some sockets on the bench. And I've also put an overhead LED batten light, which you can see there, just to shed a bit of light on things. So let's have a look, see how this comes apart. Now, the person I bought it off already removed the stand because he's already had a look at the power supply, but he couldn't see anything wrong with it. Couldn't see any bulge caps or anything. So let's see if we can get this bottom off and have a look, see where the power supply is. Now I've just tried switching it on again there. I'll just try with the remote. And it is actually powering up there. See the air, and it says 100% there now. So it's actually started working again. So let's see how this bottom comes off. And he's in the bag that he sent the remote and he's put some screws in here which hold the base on and this bottom plate, I think. Right, let's see. And this comes off then. Looks like there's some clips there. I'm just going to grab a spudging tool. Oh, that's not really doing a lot. I think I'm going to need a bigger screwdriver or something. Let's try one of these. I'll just unplug it as well. Well, that clip came up, but the other ones don't seem to want to. Let's take that side off. So that one off. And there we go. So it looks like the mains comes in here. And it looks like we've got some kind of safety switch, I guess, so that's on the cover that you remove to access the filter. So that just disconnects mains power. And this is the output here. Tell you what, I'll go and get the test meter, I'll just see what voltage we're getting off this power supply. Ooh. 15.6. And I'm sure this is only supposed to be a 12 volt power supply. Right, I'm just going to switch that off. I'll tell you what, we'll just try it with a load on, just in case the power supply drops when we switch the unit on. So let's switch it back on again. I'm just going to use the remote here just to switch the fans on. Still nearly 15 volts. Right, I'll switch that off. So it looks like the power supply is putting out too much voltage for some reason. I don't think I've had that before. So I wonder if there's some kind of design fault with these power supplies. So I think we'll take the power supply out first, and we'll get that over the blue mat, and then we'll take the display part off. I'm trying to get the display part off the top there. I'm not sure how successful we'll be with that because it looks a bit of a nightmare. So I'm just going to try out this thing here, which somebody recommended, one of my viewers. It's a Klein Tools 65200, and it's good for getting into tight places where you can't sort of get a normal screwdriver in. So it's got a little ratchet on there, and then you use the thumb wheel on the top as well. One screw out. Right, that's the power supply out. Right, let's see how the top part of it comes off. So it looks like this whole top section wants to slide that way, but then it's sort of jammed with clips at the top here, so I'm going to have to see if I can release these clips up here. But if it's anything like the other Shark products I've looked at, they're a nightmare to get apart, so we'll see how we get on. So I've managed to slide this top part forward, which has allowed it to lift up a bit here, but there's 4 clips right at the very front. I don't know how well this is going to show up on the camera, but you can see one of them right at the back there. You can see the little bit of a black line. That's one of the clips there, and there's one next to it, and there's 2 more at that side. So I'm going to try and get a spudging tool in the top just to see if I can release those clips. Yeah, I don't think these are designed to come apart. Let's try this side. Let's just bend a spudging tool here. So this might be a bit destructive, I think. I'm going to get the spudging tool in this side. Right, screwdriver it is then. That's a bit too big to fit in. Let's try one of these plastic spudging tools. Well, something seemed to go there. Oh, I've got cables attached. Well, I actually got that off without any damage, I don't think. Right, let's see if I can plug this top board. That looks like one of those display chips. An LED driver chip, if I remember right. Let's just have a look over at the front panel board. That's the 6 quite large fans that's in here. It looks like they all go to a common power board here. And this looks like the front panel display board. You might be able to hear the sheep in that in the background. I've had a few people asking about the flock and the animals, so I might put a bit video up of those a little bit later on. We've also got something down there. It looks like something aluminium, maybe. Something blue down there, aluminium. Let's see what that is. So I've just flipped it over, and this is a T20 security Torx. Let's get this little flap up. Oh, what's this little gizmo? So I wonder if this is the air quality sensor. It looks like it's got a little fan there. PM sensor, yeah. So that's what measures the air quality, and that goes through to the other side. And it looks like we've got a little connector here, which might be for programming the microcontroller. Right, I'll get the display board out. So it looks like we've got 3 screws at this side, and 3 screws on this side. And possibly more of those horrible clips. Just down here, 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 and here. So I'll have to see if I can battle with those next. Well, I managed to get the other clips out, and this is pretty much the guts of the machine here, apart from the fans. So what I've done is I've disconnected this little subboard here where all of the fans plug into. That goes to this board here. And I've also removed the little board that was on the front of the machine, because that's where the remote IR sensor is, just here. That's the air quality sensor, and that's the power supply. And what I've done with the little interlock switch there, I've just used a bit earth sleeving, just bent over there, just to keep the micro switch pressed, so it thinks that the cover's on. So I'm going to plug it into the dim bulb tester, which I've just got just here. It's just off camera there slightly, just in case it decides to blow up. And I think that's plugged in. Let's just try the remote. Yes, there we go. And that's the power light that's not working. And some of these other lights don't look quite. Looks like there's only one of the LEDs working on that one. So let's just double check what the voltage is on this power supply. I'll just zoom back in a little bit. Yeah, we're still at 15.6 there. I'm sure on the board it's marked 12 volts just here, so I've got ground and 12 volts. Yeah, and 15.6. Now let's switch this back off. And there's some writing on the power supply here. I'm just going to disconnect it from the mains. If we zoom down there, let's see if I get that in shot. It says there, output 12 volts. But it's giving out more than 12 volts, so I think there's a problem with the regulation on this power supply. That's one problem anyway. Let's have a look at that first. So I'll get these other parts out of the way. Let's have a look at this power supply. I guess it's a custom part for Shark Ninja. And we've got a little optocoupler there. And the way these power supplies should work is this side of the optocoupler, when it reaches the correct voltage, should have 1 volt on it. And that tells the power supply chip here to stop oscillating, and that's how it regulates the power supply. So let's see, this is kind of glued on with some of this goop stuff. Let's see if we can get some of that off. Let's try my probe there just to see if we can. try just pulling it off. There we go. I'll just unplug this little switch. And there's not much on this side. I can't see anything that would cause a problem there. So I think what I might do is just get this under the microscope, then we can have a look over these components a little bit better in detail. I'll just set the microscope up. Right, got the microscope set up, but one thing that I forgot to do was to check if there was any voltage in this capacitor still. And yes, there's about 325 volts in there still, so I think we better discharge that before we go any further. So I'm just going to use the capacitor discharger that Dan Wilson kindly sent me, that he designed. Right, that should be that discharged now. Let's just double check with the meter. Yeah, about 6-7 volts in there should be fine. I'm going to get a zap off that. Right, so let's have a look on the underside of this board. So this is the low voltage side. That's the output just here and here. I've got a few 0 ohm resistors. It looks like there's a small 6-pin IC there, I don't know what that is. Let's just see if we can zoom on that a bit. And it looks like MA0L111. So I'll see if I can find a data sheet for that or what that is. We've got a, looks like a diode just here. Another 0 ohm resistor, and that goes to the optocoupler there. So this should be the LED side, and that side will be the photo transistor. It also goes through a 0 ohm resistor, and then to the regulating IC here, and that's an M14241. As you can see, we've got some conformal coating on here. I'll just zoom back out a little fraction on this. See a little transistor or MOSFET there. There's not really a great deal on this power supply. I've got some of that silicone goo there. So again, can't see anything obvious. So I think what I'll do, I'm just going to see if I can find any information on what this little IC is here. This MA0L111. Well, I've had a look around the internet and I couldn't find any information on this chip. The only thing that I did find was an MA0, and that was a voltage detector IC, but it didn't have the same pinout as this. So then I thought, well, what's it connected to? So I followed the traces, and it goes to this component here. Now this is the output of the transformer, so the secondary. They're using this side as the ground, and this side is the voltage out of the transformer, and it goes to this pin here also. But when I flipped it over, I was expecting a diode, but it's marked Q2, and the diode's missing. So I thought, what on earth's going on here? So I tried to look up what this part was to see if it was indeed a diode or a chip or whatever. and I couldn't find this part either. But what did come up was a Japanese page where somebody was doing a teardown on a power supply, and it said something about synchronous rectification, and that's something I've not came across before. So what happens is we've got this little chip, wherever it's gone, I'll just try and find it again. Here we go. So we've got this little IC here, and what that does, it detects the phase of the AC coming out of this transformer here. And when it's, let's say, on the positive cycle, it switches this MOSFET on to allow current through. And when it goes to the negative cycle, it switches it off to block the current. So that's how it works like a diode, because it only lets the voltage through on the positive cycle, let's say, and not the negative cycle. So they're thereby acting like a diode. And the reason why they use a MOSFET to do this is because they've got very little resistance, whereas a diode has got a voltage drop. So they use the MOSFET for better efficiency. So that's what's going on here, because I was a bit confused at first, but I understand it now. So I went down a little bit of a rabbit hole on that one. So I still haven't figured out why this is overvolting though. So let's try and trace this through. So we'll come from here, we'll go through a 0 ohm resistor, and then that goes up to here, doesn't go anywhere there, or does it? Yes, it goes to this transistor here. And one of the other things I noticed as well, we've got this big 0 ohm resistor here, which I would have thought would be for current sensing, but when you trace through, it just doesn't seem to go anywhere. It just goes to that pad there. And also we've got this here, which when we flip it over, it's just a big wire link across the same place where this resistor is. So I don't know whether they've had current sensing and they've just decided to do away with it or what. So I think we should start checking some components. I'm not sure what that transistor thing is there. Looks like 9AU. Let's go on to diode check here. Oh, we don't have any shorts. It's a bit hard to see with this conformal coating on there. It's a bit better if I angle the board. I'm just going to use the remote just to prop this board up a little bit. Let's just check some of these resistors. So we've got 43k. I wonder if there's some voltage left in one of the capacitors here or something. If there's anything in these output capacitors, let's just check. Nothing in that one. Nothing in those. Just don't understand why I was getting a bit of a weird reading there. So that looks a bit odd. It could be just other things in the circuit. Yeah, we're getting some odd readings on some of these resistors. Let's just try some of these capacitors for shorts, I think. Just try some of these 0 ohm resistors. And that one's just got a big wire link across it anyway. Now, because these are in parallel, we'll probably have to remove those to measure them correctly. So they appear to be in parallel. That's probably about right, actually. $10K. So the only ones I'm getting odd readings from seem to be these two, I think. So I continue to check lots of the components on the board. I check capacitors for shorts, I check the values of resistors, and everything pretty much seemed alright. Oh, can't see anything up to now. I'm just wondering if it could be something to do with this active rectification or whatever you call it. But I still would have thought it would have been regulating down because it should be measuring the voltage. Kind of struggling with this one at the minute. So it looks like this transistor here switches on this LED. And we've got a voltage divider here by the look of it. So there's a 43K. And I think that one's an 11K. And I wasn't getting quite proper readings on there. I mean, I'm getting about 10K on there. But it could just be because there's capacitors and things. So what I might do is just remove those resistors just to check them, just in case. So I'm going to put a bit of flux on first. And then we'll just add some fresh solder and see if we can just move those along to one side or something. Something like that. So 11K and 43K, so they're right. Right, we'll pop those back then. Well, I'm a bit stumped with this one so far. I wonder if we get 1 volt on here. I might connect this power supply back up to the mains. Go into voltage. Let's couple this back up to the mains, and we'll have to remember to discharge the capacitor after we're finished. Right, let's try and get this in shot. Right, I'm just going to power this on now. And we do get 1 volt there. Let's just see what we've got on the output. 16 volts. It seems to be jumping all over the place. I'm wondering if it's something to do with this. Now in theory, we should be able to do away with this part and just put a normal rectifier diode in. So I don't know whether I might just try that. Because I can't get that chip, and I've only seen one mention of this component here, like I say, on an obscure Chinese site. So I'm just wondering if this part of the circuit's okay and it's something to do with this here switching power through at the wrong time or something. I don't know, I can't really think of anything else to try up there now. And it has got the place for a normal rectifier diode, so it should just be a matter of pulling this component here and fitting a rectifier diode there. Right, I'll go and sort that out, I think. So I found a rectifier diode off an old battery charger. So this is a Schottky rectifier diode. That's the output from the transformer. It's going to go down into here, get rectified, come out, and then go to the positive rail, which is just here. So I've got no idea if this is going to work or not. It might fail spectacularly, but I'm just about to switch it on. So, well, it didn't blow up. I'll just switch it off quick just in case. Let's just see what voltage we've got. Right, I'm just going to try that again. Oh, look at that. A lot. It does seem to be dropping. Interesting. It did get to the 12 volts. Actually, it went above it there, it went to 13. So possibly not that then. I thought we might have been onto something there, but I guess not. Well, I've spent a bit of time testing different components on the board and I still can't find anything untoward. So I'm just wondering if it could be the IC. I even found a capacitor down here that I've missed, this little one here. But I've checked that with the Peak Atlas Gold and it seems to be okay. And I've even checked the mains cap as well. So I'm just kind of suspecting this chip here now. So I might order one of those and see if that makes any difference. It's an OB52. I think that's 82CP or 32CP. It's a little bit hard to see with the conformal coating. So I'll order one of those, we'll try replacing it and we'll see if it makes any difference. So this is the following day and I've ordered a new IC that's coming from China, so that's going to take about a week to get here. But during the night it was kind of niggling us that I'm not so convinced that it is the IC. And one thing that I've noticed as well, I touched the board up for dry joints, you know, just as you do, you know, that one looks a bit suspect, so I went over some of the joints, it didn't make any difference. But now it seems that the board doesn't want to start up at all. It just, as soon as you apply power, it just trips off. And that got me thinking about the symptoms, how it used to cut off when it got hot. So I thought, well, what have I touched with the soldering iron? And one of the things that I touched, or touched up, was this opto-isolator. So I was thinking, could the opto-isolator have gone faulty? let's suppose like one of the bond wires inside, and when it heats up, the bond wire breaks with the thermal expansion, and that shuts the power supply down. So that's kind of where I'm at. So I was thinking, how can I test the opto-isolator? What would be an easy way to do it? And then I remembered that ages ago, I think in one of the comments, somebody mentioned about you can check the output side of a power supply by powering it up with the correct voltage, and you should get 1 volt on the cold side here. So I thought, well, if I power this up, I should be able to check or diode check the other side to see if the diode's working. So that's what my plan is. So I'm going to go on to diode check. Actually, I want the volts first. I've already unsoldered this half of the opto-isolator, so we should be able to just prise that up like that. I'll get the bench power supply. I'll just hook that up to here. And I've got it set to 12 volt at 100 milliamp. I'll just switch that on there now. And that's up to voltage. So let's see what we've got here then. So we've got 12 volts there. So on this side of the opto-isolator, we should have, well, I've got 0.9 of a volt. So let's see if we've got anything on this side on diode check. Well, I've got nothing that way. Let's try the other way. I haven't got anything that way either. I'll just zoom down a little bit. So I've got nothing that way. Just check my probes are working. I'll just swap those around. I don't appear to have anything that way. So let's try the same thing on another power supply, because I've got a few blown power supplies around, so I'll just go and grab one. So this one is an old 24 volt power supply that somebody gave us to see if I could do anything with, but it was a bit, yeah. So I thought, yeah, it'll just do for parts of that, if anything else. So what I've done, I've lifted the opto-isolator, same as what I've done on the other power supply. And this is the input here. So let's just measure across this side. And we've got nothing that way. Nothing that way. So now let's power it up. I'll just connect the wires up there. And this is 24 volts. I've got the LED lit up there. Now we'll just measure across the opto-isolator. I'll just get in there. I'll zoom down a fraction again. So we've got nothing that way. And we've got a reading. Right, so if I zoom out a bit, and I'll switch the output of the bench power supply off. And now we don't have a reading. I'll just switch the output on again. And we do have a reading. So I think that kind of confirms that the problem seems to be the opto-isolator. So this is the original opto-isolator that's on the little Shark power supply. And it looks like 817MC. And there's another number on there as well, which is F116C. But I've searched both of those numbers and nothing's coming up. So this is the opto-isolator which I'm thinking about replacing. So we'll try this and we'll see what happens. I think the worst that'll happen is it'll just do exactly what it's doing now, pretty much nothing. Right, I'll get this soldered in then. Right, that's the old one out. Let's solder this new one up. Just bend the legs a little bit just to keep it in place. Right, let's zoom out a bit and hook it back up. I've still got it connected to the dim bulb tester, so hopefully it doesn't explode everywhere. Let's check we're not having it on bits of solder or whatever. Let's grab the test meter. I'll just zoom out a bit more. Right, I'm just going to plug this in. And in 3, 2, 1. It sounds like it's doing something. Well, that looks better. $12.2. I think that might be it. So I've ordered some chips which I don't actually need now. Well, not to worry, I think it was only a £5 or something for the chips, so right. I think that's it sorted. The power supply anyway. But I don't think I've had a faulty opto isolator before, that's why it kind of threw us, but that seems to be what it is. I thought I'd take an x-ray of the opto isolator just to see if you could see anything blown inside of it, but it didn't actually reveal a lot. I was just curious to see what it looked like. So I think the next thing that we need to do is have a look at the main control panel. So I'll just get that and I'll hook that up. Control panel's all hooked up with the power supply. I'll just switch it on. Now this should be the power button. If you see, it's not lighting up. And also there should be 2 lights lit up here that go bright and dark, like those 2. I think it's just saying it's an error because I can't detect the fans or whatever. So it looks like we've got 1 LED gone down there and 1 LED gone down here. So I don't know whether to change both of those ones in there. So I might end up changing 3 of them. And what I've done, because I was looking around for LEDs, I found this old, I think it was off a downlighter or something. So I've just pulled the LEDs off there by heating this from the bottom. It's an aluminium board. So I don't know how well these are going to work for heating up. Keep touching the off button there, because I might end up melting stuff on the back here. There's capacitors and that stuff if I heat the board from the bottom. So I might have to try and solder these on with a soldering iron or something. But I'll unplug it all and then we'll remove that spring and then we'll try and change these LEDs. Right, so I'll just unplug everything and I'll get those springs off. And I think that connector that I thought was for programming might be for a different type of air quality sensor, because it has got the connections written on down here. And we've got TXD, RXD, 5 volt, ground, and SWUI, whatever that is. And the other sensor has also got TX and RX, 5 volt and ground. So I'm just wondering whether it could be an alternative type of sensor with a different plug on. I'll try and desolder this spring first. I'm just going to add a little bit fresh solder. That's one of them removed. And I can't remember which one it was now. I think it was that one. It was that middle one there. Right, that's that one off. Right, I might do that under the microscope. Right, so that's the first LED. I'm just going to add a bit of flux. I'm going to use some low melt solder just to make it a bit easier to remove it. Well, that went quite well. I'll just clean this up. I'll use the solder sucker on that hole. And get the old LED out of the way. If you notice, it's got a little black mark just in the centre of it, just there. I think that's where it's blew up. So this is one of the replacement LEDs. Let's see how we get on with this. Maybe better to put some solder on first, I think. Well, I think that might do. I'll just put the meter on diode check. And we'll just see if it lights up. So I'll just try switching the board on, it's an idea. No, it doesn't light up. So I did a few tests and I realised that these LEDs that I was using require a lot higher voltage because they're from a 240 volt light fitting, so I think they're about 15 volts. So then I remembered I had the old Noco boost pack that had the failed microcontroller, and that's got some white lights on the side, so I figured I'll try one of those. So I've just soldered it in. So let's switch this on. And it does light up. Excellent. Let's see if we press next to the side of it. Yeah. Right, power light's working. Right, we'll do the other two then. I'll just switch this back off and I'll get the other two changed now then. I'm just going to spin this board around a bit so I can get a better angle with the soldering iron. I'm just going to add a bit of flux to these LEDs. And put some low melt on again. Right, there's the old LEDs removed. I'll just clean off the low melt solder, which doesn't want to seem to clean off for some reason. Let's put a bit more flux on there. I'm going to put some regular solder on and then mop that off with some solder wick. Right, I'm going to put some fresh solder on here, and then I'm going to use the Rework station to melt this first, and then I'm going to turn the Rework station down just to drop the LEDs on. That's kind of my plan anyway. Right, so that's the solder melted, so I'm going to turn the heat down to about 290. And hopefully I haven't cooked those. Right, let's switch it on. And yes. Hey, there we go. Both lighting up. Excellent. So I think that'll probably do it for the control panel. So I think the next thing is to put it all back together. Well, I've just finished putting all the connectors and the power supply and everything back in it. So I've got the power supply there. I've got the little board connected up in the middle, the little distribution board. I've got the front panel connected back on, and I've got the front panel display connected back up as well. So I haven't plugged this in yet, so we'll see what it does when I plug it in. Well, I've got a power light. I can hear the fan starting to kick in. I think it thinks it's a bit dusty in here. Probably right, because it's a workshop, so the air quality's gone down to about 92%. Probably be about right. So let's measure the voltage on the power supply. Nice. 12.04. That's better, isn't it? Excellent. So I think what we'll do, we'll leave it on test for a bit. I might put this back together now actually, and then I think we'll give it a final test. Well, it's 6:25, so I brought this in the house. I'll switch it on. I think we'll just leave it to do its thing. And we'll come back in a couple of hours and we'll see if it's still working. Well, it's been running quite happily now for the last 2.5 hours or so. It's the time there now. And I've tried the auto button as well, because before that was making it go off. So it looks like the main fault with this was the opto-isolator and just a couple of the LEDs. And why it took us so long to find the opto-isolator was because I tested the diode side of it, that measured okay, and the other side of it, the photo transistor side of it, or photodiode side of it, is normally open circuit. So that's why I didn't really suspect the opto coupler. So anyway, at least it's all working now, so I think we'll call this one a fix. And just another little bit of an update, it's now 1:15 AM. And it's been on continuously since then, so definitely working 100%. Now I know quite a few people have been asking about the animals and that and stuff, so this is one of our valet's ewes, and that's her lamb. That one's called a spitty lamb because of its markings. It's like got incorrect markings. It's not the same colour as her, if you notice. It's more like a speckly coloured, where it should be white with black markings on its knees and that and stuff. We didn't think she was pregnant, but she lambed later, so that's why she hasn't been sheared. I guess this is one of the friendly sheep. Hey lass, you're hot. Yeah. Some of the horses in the distance there. I'll have a wander over there, I think. So this is Storm. She's pregnant at the moment. I think she's about 5 months, so I think she's about another 6 months to go. This is Birdie, who was born here. He's a little colt. And that's his mum over there. I think Birdie's still a bit unsure of people at the moment. He might come over. No? This is one of the little valley lambs that we're bottle feeding this year. Yeah. Not that nice. Are you having a whittle? You coming? Come on then. No, too busy munching grass. And here's Harriet. Hello. Hello. Yeah, Harriet's been sheared, so she hasn't got a coat on at the minute. She hasn't got a big woolly fleece on, so yeah, Harriet. Yeah, Harriet's Valet's cross. That's the other two Valleys lambs that would be in there. Hey, come on. These are all having a rest. So I hope you enjoyed that little bit of a tour there.